Well, hello, everybody. Good afternoon or good morning, depending on where you are in the country. My name is Garrett Schmidt. I'm the managing editor for BBC Exhibit Hall, and I'd like to welcome you to today's live webinar hosted by Edifecs, and it is called Meaningful Applications for Healthcare AI. And I'm about to, in a moment, I'll introduce the speakers that are on the screen there. But just a couple items of housekeeping before we get started. This is a traditional webinar format, so you don't need to worry about muting your microphone or turning off your camera or anything. We can't see you or hear you, so don't worry about that. But we will have a time for some Q&A towards the end. So if you have a question at any point during the webinar, please ask that question using your control module. There's a place for questions, which is different than the chat. So just drop it in there. And we're going to get to as many questions as we can. And we have a big audience today, but we're going to get to as many as we can. If we don't get to yours for some reason, don't worry. Someone will reach out afterwards via email to answer your question. And also today's session is being recorded. So when we're done, about an hour or so after we conclude, you should receive a link to the recording where you will also be able to download the slides. And there'll be some other information there as well as how you can get in touch with our speakers today. All right, well, without further ado, I'd like to very briefly introduce our speakers today. We have Mr. Chris Lance, who's the Chief Product Officer at Edifecs, and also Niraj Katwala, and he is the VP of Technology. So welcome, gentlemen.
Thanks, Garrett. Glad to be here.
Okay, Chris, I'm starting. Okay. Hey guys, hi everybody. So we are going to first do a level set on AI, and basically just describe, like, when you're talking with amongst yourselves within your organization, or when you're talking with potential customers or thinking of new products, what is the level set that needs to happen amongst all the people, right? So what we have in front of us is a slide which describes all the major verbiage which is used in the AI world. Okay, there are three types of algorithms. There are what are known as regression algorithms. There is classification algorithms, and then there is the generative AI algorithms, which is the new thing which originated, I would say, in the last 12 months or so, even though it has been around for a longer period of time. So regression algorithms are algorithms which typically go into uh, predicting the cost of something in the future. Okay, so think about it that way, where that algorithm, or those sets of algorithms, they predict cost of, let's say, a house, or they predict future price of a house, or the future price of a stock in the stock market, or if you are more focused on healthcare, then it would predict, let's say, the cost of a particular treatment procedure, or all the treatments, that's known as an episode of care in the future for a single person in a geographic area or at a particular hospital. So over there, we are not dealing with any text. We are mostly dealing with numbers. And you are effectively massaging numbers and then looking at historical data and coming up with future prices based on that. The second type of algorithms are known as classification algorithms. Classification algorithms go and bucket things into different silos. So let's say you are in an organization and want to figure out the incoming emails, which emails happen to be spam versus good emails, right? So that's where you would use classification algorithms. Or in the world of healthcare, you want to predict the list of ice, or bucket a chart, a patient chart or a patient between all the different conditions that he may be suffering from. So is he a diabetes patient, and hence he will have this ICD-10 code, or is he a cancer patient, and then he would have a different set of ICD-10 codes. So basically it's putting the target list of data into separate buckets is what classification algorithms do. And finally, what really took hold over the last, I would say, 12 months are generative AI models or algorithms, which allow you to do things like summarization, language translation, writing Java code, or Python code for that matter. Or these models are basically what they are doing internally is converting text into a series of numbers, and then those series of numbers are massaged, and then they get translated into text again. Okay, so that's the process which these generative AI models follow. And by layering classification and regression algorithms, above it, below it, you can actually use these generative AI models like ChatGPT, which has become so famous, for different regression and classification tasks also. That's why they are, because they have a broader range of applicability, they have become so famous. And the regression and classification algorithms are 30, 40, 50 years old, some of them like linear regression. The generative AI models are more recent. I'll just add a couple of more thoughts around natural language processing and machine learning. Natural language processing, all it is doing is it's breaking up a set, a chart, let's say a patient chart, into different words and trying to understand those words. Okay, so it's an adjacent technology which can benefit from AI, but there should be no confusion of whether it is AI or not. It may or may not be AI. It is related to AI though. And finally, there is machine learning. Machine learning is the aspect of actually training the AI model. Okay, so whether it's a classification, regression, generative AI model, the process of actually training that model, right, is machine learning. So in machine learning, you take data from historical data, and you use that data to fine tune your model so that in the future it can predict the or do the job that it's supposed to do. Okay, um, that is what machine learning is. So that is just an overview of all the different major items that you people typically talk about in the world of AI. Okay. Next slide, please, Chris. Okay, so what really happened? This slide covers like what really prompted the absolute explosion in the world of AI over the last I would say last November, right, 2022. Well, in about 10 to 15 years ago, there was a major breakthrough. The NVIDIA leaders, Jensen Huang and all those folks, were actually in a meeting where they were discussing machine learning. I mean, NVIDIA happened to be a GPU company. GPU meaning all they were doing was taking an image and painting it on the screen, right? Like you have a 728 by whatever 512 screen, and you are taking a photograph and showing it over there, or you're showing a video on the screen, and their chips, which they had developed for since 1999, were very good at doing that. They were very fast at displaying that on the screen. Well, what they discovered in like just total serendipity, what they discovered was the same algorithms which were used in this graphical processing chips, known as GPUs. they are the algorithms are for machine learning are very, very similar. Okay, so in a very bold step, Nvidia said, hey, we are going to go after this market rather than go after or stay with our I mean, they were a profitable company at that time and doing well, but they made this decision that we are going to pivot our company towards ML and AI. And the result is that the cost which was being incurred by companies to do the processing of the data, the machine learning of the data, the training of the AI models dramatically reduced. So this really propelled the world of AI over the last 10 years or so. Okay, because cost is always very big, right? If you can do something for almost free by doing it manually versus spending hundreds of thousands of dollars for a little bit better or significantly better, then so this took away a very big aspect of the cost feature, and then other companies also joined into the CPU bandwagon. Then the second thing which happened, more on the software side now, was that there is a group of scientists within Google, the Google Brain group. What they came up with is this paper which says attention is all you need, and that led to a different type of model, AI model called the transformer model. And this model was just superior. Like, it did a great job. I mean, it did an excellent job of, what I was describing, basically taking text and generating numbers out of it, and those numbers then getting translated into words back. And all the NLP, or translation, writing code set of tasks really worked very well with those models. Okay. And Google, Facebook, etc. jumped in, and they started building BERT and Roberta and Llama and all these models, and basically it really took a very strong foothold in the industry. Then OpenAI, which is a company owned by a gentleman by the name, you all know OpenAI, it's Sam Altman. He basically took it to the next level, where he put the power of this through ChatGPT in the hands of hundreds of thousands of users who were actually doing search, right? So search happens to be the single largest software application in the world, right? Total stranglehold by Google, like 80-90% of the market. And suddenly you can actually write questions and detailed questions and all. And lo and behold, it got such amazing reception, became one of the fastest growing apps on the web, and rest is history. And here we are today, where the greatest monopoly, which is Google, is being threatened by something like that. So basically, that's the history. Those are some of the definitions. This is the history of AI. And we are going to go into details on a specific healthcare example towards the end of this presentation. But at this point, I would like to hand it over to Chris to take a deeper dive into more of the marketplace around AI today. Chris.
Thanks, Niraj. Great overview there. And as mentioned earlier, my name is Chris Lance. I'm the Chief Product Officer for Edifecs. I want to talk a little bit about how AI has emerged within healthcare and sort of how it's being approached so far. In particular, AI, and in particular the current manifestation of AI, is very well suited for our space. Starting in kind of the early aughts, the proliferation of EHRs began to create a channel for the collection of and storage of the large volumes of data required for AI and its application, as well as a deployment method for it. So you both need models that allow you to infer or generate or classify or predict, but also a mechanism to deploy those. And the technology foundations in healthcare have been in place and established for quite some time. And then beginning as far back as the 1980s, we really started to build these massive volumes of data, both in terms of local to an organization and industry-wide, through research, through clinical experience, et cetera. And we continue to build vast amounts of data in the space. The statistic at the bottom here about how the amount of knowledge doubles every 73 days is just mind-blowing in terms of the amount of information available for healthcare and for decisions related to it. Healthcare speaks its own language and is well suited to the application of AI. So not only are there well-established standards and guidelines and constructs and taxonomies, but also it tends to be in human language and in human concepts that fit very well with AI. And then ultimately, interactions in healthcare end up being human in nature. We're talking about the healthcare of humans. And as we look in particular at generative AI and its ability to both produce and consume and make use of human language-based concepts, it becomes very, very applicable in the space and really has taken off in that regard. And so ultimately, this combination of factors makes AI very well suited for this space and creates a multitude of opportunities for innovation. However, it hasn't been a straight road and likely won't continue to be. There are a number of forces that sort of cause a push and pull effect for AI in healthcare. So we have all of the buzz and hype and interest in things like ChatGPT and other generative AI models, and demand for things like that in healthcare. And then we have all the examples of businesses over the last 5-10 years that have entered into the healthcare space with AI and absolutely fallen flat. And so what it leads to is this question of, can it actually be applied successfully in healthcare? And if so, how so? And then who is most well positioned and most capable of doing that? So we've seen a lot of non-healthcare, traditional non-healthcare companies really looking to leverage consumer technology and sort of broader industry technology to create healthcare solutions. And there's still some questions around how successful they can be in that. And so we have this technology that is clearly well suited to the space, but as of yet has really struggled to get meaningful traction. And it leads to the question of, why is that the case? The reason being that there is a lot of challenging terrain to traverse. And I think we're beginning to see a shift in a direction that makes it more likely that we're going to see success, but there's certainly a lot left to be done. And how long it's going to take for that to happen is the real question. So we start with the idea that there's an endless number of use cases that we believe we can apply AI to. Medicine is about decision making and analyzing non-deterministic scenarios, or oftentimes non-deterministic. And at the same time, there are questions about whether or not the data about an individual and their health history is something that should be trained into AI and leveraged for training for AI. You've got data coming from lots of different sources, and the old garbage in, garbage out analogy applies here probably as much as it does anywhere. And so if you don't have clean, well understood, well structured, and reliable data, then you're going to be training models on bad data, and there's risk of sort of creating bad actors, so to speak. The bar is really high. There's high side effects of being wrong in medicine and in healthcare. And so whereas in a lot of consumer applications or even financial applications, being close quickly and at high volume is more valuable than being very precise over a longer period of time. And at smaller volume in healthcare, you want to be right most of the time. Otherwise, there are meaningful side effects. And so the bar in healthcare is a lot higher than it is, I think, in a lot of other domains. And at the same time, though, we do have access to tons of information. So again, we've got this confluence of headwinds that make it a little more difficult and challenging for folks to get comfortable with adoption of AI in healthcare. And at the same time, all of the right ingredients to create meaningful healthcare applications of AI. And so what's worked and what hasn't? What hasn't worked are silver bullet approaches to AI in healthcare. And we have a couple of very, very representative examples here. All of AI, who really tried to address a large space in the healthcare ecosystem with the financial and supply chain aspects, had a huge valuation in 2020. Were very much the darlings of industry during their run, but really failed to ever produce meaningful results. So lots of opportunity, lots of great stories, lots of potential, but couldn't produce the silver bullet that they've sold to the market, and ultimately lost the confidence of the market, regardless of what technology they ultimately produce. And IBM Watson Health, exactly the same thing. So loads of data, great technological capabilities, lots of runway and credibility and interest. So they had lots of opportunity to produce results, but struggled for likely the very same reasons. And so the applications were large in scale, the ambitions were large and somewhat shaky, the costs were very high and the valuations were high, and there were questions about the security of these models as well, because they were sort of, again, one thing trying to do everything. And what we've definitely learned, and I know Niraj will hit on later, is that AI is a game of singles. Successfully creating AI-based solutions is about composing lots of very specific, very small, but very effective capabilities into larger scale solutions. So the new approach is really about doing just that. So it's about building capabilities that are specific to a need or use case or domain. And we believe that that's what's going to happen. We think that niche models will be developed based off of advancements in consumer-driven technology. And then we'll be able to compose those into useful healthcare applications that achieve the balance that we're looking for, both performance and reliability or a viability of the outputs it produces. Some great examples of that will be things like predicting missing data elements in data feeds. So rather than having manual queues to work through and correct, or trying to do fuzzy matching, literally predicting almost out of thin air what those data fields are, proactively monitoring patient health, resolving data quality issues related to social determinants and other large scale and highly valuable data assets. And so we see a path forward, but we think that the practical application is really the key there. So when we think about selecting AI technology, so you're talking with a vendor, you're talking with your internal teams, you're talking with a partner or customers, I want to share some guidance on how to really go about doing that. So the first one is, how extensively were the models trained on what data? And you can have a very, very genetically intelligent child, for example, that gets no education and isn't going to be terribly productive in specific settings. The same applies to AI. You can have a very well-structured model, but if it's not trained on high quality data and enough volume of data, then it's not going to be able to produce very reliable or tractable results. Was that data correct, or was it susceptible to bias? So again, if you're trying to build something that's generally applicable, it needs to be generally trained and generally experienced, just like any other sort of learning. It's going to replicate or mimic what it's seen in the past to produce what it's producing in the future. Is the vendor or partner experienced in AI? It is not a fast learning curve capability, both technologically and from an application standpoint. And you want to make sure that you're working with someone that not only has experience with AI, but has experience with AI in healthcare for all the reasons I just described. You really need to understand the nuances of the space, which appropriately niche models or capabilities to deploy for a given use case, and have the experience of what to do and what not to do. So you want someone that's been through that process a number of times. How well does the model change to the environment? So you don't want a brittle model in an ever-changing environment. We all certainly know that the only constant in this industry is that it's going to continue to change. You need to make sure your technology and your partner is equipped to continuously evolve, adapt, grow, and incorporate changes to the external environment, whether that be guidelines or changes in patterns of behavior or health in a population, so on and so forth. And then finally, what are the security and governance policies? So how well is the data that's used to both train the model and to produce predictions secured? How is it managed? How is it accessed? And is that within the envelope of best practices and standards such as high trust, et cetera? Then what you want to do is find out whether or not you're using AI in the right contexts. So make sure that you're choosing the right tool for the job. AI will not solve everything. As Niraj talked through, there are some very specific types of models that can be composed in a wide variety of ways, but it's not well suited for everything. And it's not going to make an impact that outweighs the cost and complexity and risk in every case either. So it's really important to choose the right tool for the job. So make sure that you're looking at business functions or tasks that are decomposable, that can be broken into smaller parts and automated in chunks if that's what you're trying to do, that you're looking for recommendations or suggestions or classifications that are narrow and relevant to a specific use case, so that you can make sure you pick the right model. Make sure you're using the right type of AI. Generative AI is not for everything. Again, as Niraj spoke, there are a number of different types of model, and you want to make sure you're picking the right tool for the job. ChatGPT is not great at predicting the stock price of Ford today. That's not what it was built for. And finally, pick winning plays. So make sure that you're building for an outcome, not just for use. Avoid trying to check the box of using AI and focus on gaining the ability to effectively deploy AI. Well, I know a lot of businesses today are looking to be able to say that they are effectively engaging with AI companies or using AI in their businesses. You want to make sure that that's something that's going to stand the test of time. Nobody wants to end on that list of companies I shared a few minutes ago. So really make sure you're looking at the right places that are going to produce the right business outcomes for you, like any other tool, and ask whether or not the solution that you're using was trained in a context that's relevant for your business. Again, I don't want to ask ChatGPT to diagnose my current health condition. I want to ask a model that's been trained on medical data and is capable of making those sorts of determinations if such a thing exists. With that, I will pass the mic back over to Niraj here.
Hey, Chris, thank you. So I was figuring out what would be a good use case to describe to the audience over here, and I had the choice between a very easy use case and a somewhat more complicated use case. And bear with me, but I have decided to go with the more complicated use case and how we are actually using it at Edifecs. The problem we are trying to solve with AI in this particular use case is risk adjustment. So, in the world of risk adjustment, you receive a set of charts from a health plan or a hospital system. A chart is text data, or it could be structured data from an EMR, which is describing the condition of the patient, right? So buried inside that 10, 20, sometimes 50 or 100-page chart of text is information which will help us determine which ICD-10 code and hence which condition the patient is suffering from. So the objective of the AI is to go through that chart and figure out that this patient has these 5 ICD-10 codes associated with it. This is probably, I consider it to be the most difficult problem in the world of healthcare. Okay. How do you take information about a patient and, by looking at text information which is produced by a physician, right, historically, determine what exact ICD-10 codes to associate with it and hence which conditions, right? So and if you can build a model like that, effectively what you're doing is replicating what a physician does on a day-to-day life. And as we all know, there is no real good replacement for a physician or a doctor today. So anyway, how do we do it today? So first of all, there is a production infrastructure, which is that orange box. I'm going to go left to right. Okay. So there is the production infrastructure, and that production infrastructure is where the NLP is running, right? And or the AI is running currently, and charts are coming in from all our customers, and results are being produced and being sent. So that's a standalone thing. Well, what we have to do and what we do today is that every time a new chart comes in, associated with it would also be some claims data. Claims data is, that, hey, this is the claim which was submitted by the hospital to the health plan for reimbursement, right? And then the patient information would be in that PDF or a chart. The chart is typically comes to us in a PDF form. And then finally, in the same coding infrastructure, there is an application which is going to go and allow coders, HCC coders or some other DRG coders, but in our world it's HCC coders, to go and actually human review the chart after it is NLP processed. The recommendations are human reviewed, and the correct codes are agreed upon by the coders, and that is what gets submitted to CMS or to the health plan, depending on what the customer is supposed to do. Okay, so when we are doing that, we are capturing the chart, the results of the coder actions, like what codes they accepted, and the claims data. So these three pieces across all our customers over the last several years, right? Together, all those three things constitute basically the training data that we have for training our AI models. Okay, I just want to make sure people understand that is what we call the data warehouse for training data. Okay, now we are talking 6 to 7 million charts which have been accumulated over the last few years. So now what do we do? So now we have the data. Now we choose three models, and we have chosen. If you look at the three train boxes, we have chosen a BERT large, which basically a model from Google. We have chosen Roberta, which is a model from Facebook, and we have chosen AAN, which is a traditional deep learning model. It's a basically artificial neural network, which we have chosen. And these three models are what we are going to train using the training data that we have collected over the years from our various customers. Okay, so there is a step in between. From the charts, I was explaining the features, right? The features are specific elements of data from the training data that we use for the training. So in case of the BERT Google model, we are using the sentences which contain the name of the conditions which led to the ICD-10 codes. Okay, so basically there is this huge chart, and inside this huge chart there are sentences. There could be thousands of sentences, but there are some specific sentences the coders selected and said, okay, this sentence and this phrase in this sentence meant this ICD-10 code. So, and we know what those sentences are because these charts have already gone through the coding process, right? So now we go through the 6 to 7 million charts. Today it's about 7 million. Collect all the sentences out of each one of them, which have some evidence of a ICD-10 code, and that set of sentences gets fed to the Google BERT model, and the Google BERT model gets trained on that. Okay. Similarly, we train the AAN model with concepts. Concepts are clinical terms which are associated with the ICD-10 code. So it could be the symptoms of the condition, it could be the treatments, the medications, the labs which are associated with that condition. And we collect all of them across all the 6-7 million charts, and that is what we feed into the AAN. And then finally, all the entire chart text we feed into Roberta. Okay, so that is how we are feeding, selecting the training data. Those are the models that we are doing. And then basically, after we have done it for multiple epochs, basically running it over and over again for all the 6-7 million charts, we have trained models which we then save to disk. So that is what happens in the last step where I'm saying save sentence data, save concept to code model, and save chart to text model. Okay, and at this point, training is complete. Okay, now we have trained models. So basically, what the coder or human would do, on the like the human effort, the same stuff would now be done by these three models. Okay. So this slide is what we call the training slide. So for every single use case, what I ask my developers or our architects to do is we have two slides to explain the use case. One slide would be for training purposes. And then Chris, if you can go to the next slide, please. Okay. Now, the next slide over here is talking about the inference. So training effectively trains the models that we have selected using the training data that we have. The output of the training is the three models that we created. Okay. Now, these three models are moved into an inference production environment. So what happens in the inference production environment is now a new chart which has not been coded yet comes in, right? Like some customer sends us this chart and say, hey, which ICD-10 code should be associated with this chart, right? So now at that point, what we do is we take that chart apart and we extract out of that chart the list of sentences, all of the sentences. We have a process of extracting all the clinical concepts, and then we have a process of extracting all the chart text. Those three components now get fed into the trained models. Okay, so now the trained models effectively in the past, in the previous slide, what we were doing is that we were training these models using similar data across all the 6-7 million charts. Now we are taking the information from a single chart and then feeding it to these trained models and asking the models, okay, hey, which ICD-10 code should I have for each one of these, right, for this particular chart, right? So BERT, the BERT model, which is basically the sentence model, tell me which ICD-10 code should be associated with it. AAN, tell me ANN, tell me what ICD-10 codes, and each one of those three models are going to come up with a set of recommendations. Now, NLP, AI, these are still nascent technologies. none of them, at least in our world, if somebody has a claim that they can do it 100% accurate, then I would be very impressed. But I know for a fact that there is nobody out there who is like that. So each one of these models will produce a set of codes, which I believe in our case, they are anywhere between 60 to 80% accurate, right? So what we do is do something called ensemble learning, where we collect the list of codes from all three, right? And basically we assign like, hey, all three models associated or recommended this code. And 2 out of 3 models associated, and this was the weightage which was given by each one of them. That is how we eventually come up with the list of ICD-10 codes which are associated with a patient's chart. Okay, so I hope this made sense. These slides are going to be available to all of you. If you have any questions, please ping me and I can explain in even more greater detail. But effectively, in any AI use case, you are first going to train, and then once you have trained your models, you are going to use those models in a production environment for inference purposes or making them do the task which you want them to do. Okay. So that's the use case. It's the risk adjustment use case. We use 3 models. We use the training data, which happens to be patient charts, claims data, and the coder actions. That becomes inputs to the training. And then once the models are trained, we take one chart, that comes in, or every chart which comes in, and then use the information within those charts to feed to those models to come up with recommendations. Okay. That's what I had for the use case. I have 2 more slides. So Chris, if you can go to the next slide, please. So here, it is important. So basically, this is just closing slides, and I wanted to make sure people understand that I truly believe that AI shouldn't be, now that we have, AI is real, like it's possible to do it. There is enough training data, there is enough hardware and good hardware to train data. The algorithms are more sophisticated than they were ever before. Uh, all corporations, individuals shouldn't just jump into going and building out new use cases to use AI. That, hey, we have AI, let's do something with it. No, what you should do with this newly found vigor that we have around AI is to try and improve the effectiveness or the correctness of the existing work that you're doing. How can you reduce the human effort that is out there, right? How can you, so basically in our world, we had coders, right? So those coders needed help, and the accuracy we were getting with our older pure NLP minus AI models was say 60%, right? When we started using AI, we were able to jump up the precision and recall by about 10%, right? So that is how I want everybody to think about it. Okay, hey, I'm already doing this work. Can I take AI and imbibe it within the use case which I have and make it actually, my use case more robust? Or no, by doing that, can I reduce the human effort which is involved, right? So choose your models, choose your use cases, and then once you have done that, go back and see, like, do you have the training data for those models? If you feel you have the training data, collect that training data in a data warehouse in a proper manner so that it can be reused over and over again. Okay, because training the models takes time and effort. So if you have properly collected the training data, then it will really go a long way in in setting up. Train your people. The software developers which you have should be the same people there shouldn't be new AI engineers. Maybe you hire 1 or 2 AI engineers to go and train your current staff, but every employee in the organization should be actually trained with AI, right? Just like we think about security and we think about performance and we think about quality assurance and producing quality code. Everybody should train themselves a little bit to know that, okay, I'm going to be working on this. How can I use AI in it, right? That is how it should be thought about, okay? So And obviously, it's not a threat, it's a tool. It will make your life easier, make your work better, so on and so forth. Okay, last slide, Chris, please. Thank you. So it will take a village that, this is a game of singles, and what we mean by that is that don't expect to suddenly change the landscape of development that is happening in your organization or the value you are getting out of your current investments. But the value is real. Okay, this is not a fad. This is an absolute thing which is happening. This is not going to go away. This is the underlying algorithms. I mentioned the NVIDIA thing, right? They have already got a fifth generation GPU specifically targeting ML, right? Every large organization like Google and Facebook, they are building their own GPU. So newer and newer models are getting built out. I know personally about at least 10 other companies which are working on healthcare specific models, right? So this is real, this is happening. If you don't adopt it, you are going to be left behind. So make sure that there is a strategy, AI strategy, which is there in your organization. It should not replace your product strategy, it should become part of your product strategy. And if you do that, you will really reap good benefits out of it. Okay. Um, I think that's all I have. Um, Chris, anything to add to this?
I don't have anything specific beyond the material that's in these slides. I'm not sure if these were on our list or
Yeah,
not.
I think we should open it up for Q&A at this point, unless you feel otherwise. So,
Okay,
right?
wonderful. Yeah, well, this was a fantastic presentation, and we do have a lot of questions that came in. So, and we've got a few minutes to do that. If you have a question, go ahead and drop it in now using your control module, and we're going to get to as many as we can. If we don't get to yours, someone will reach out via email afterwards. So let's dive in. First question is this: which aspects or functions of healthcare do you think will be the last to adopt AI solutions, and why?
All
Um,
right, you want to hit that first?
Yeah, please go. Oh, you want me? Okay. I think the most difficult one, as I said, is clinical decision support. So pure clinical decision support where it is kind of replacing the doctor, right? I don't think it's going to be the last. People are going to start working on it today, are already working on it today. But that's going to be the one which is going to take the most amount of time. And there is no intention, at least on my part, of replacing the doctor. I just want to be clear. I'm just saying that that is the one which is, in my opinion, the
Mhm.
most difficult use case.
Yep. And I think that the less deterministic the domain, the longer term it's going to be. So, I think when you're training AI models in particular, you're trying to train them on a right answer. When there is no right answer per se, that becomes a much more challenging sort of prospect. And I think so that the combination of non-determinism and high risk of being wrong or high cost of being wrong, those are the areas that are most likely to be sort of on the tail end. And I think as Niraj hit, when the doctor touches the patient, that's where those two things really surface, I think, most acutely and most obviously.
So where there's the most nuance and qualitative kind of touch
Yeah, and
required?
subjectivity to a large extent as well. Like if
Subjectivity,
you got
yeah,
a
sure.
room full of doctors that wouldn't agree on the answer to something, Niraj, feel free to disagree, but I think that'd be one that'd be difficult to train a model on.
Yeah, no, absolutely. That makes a lot of sense. Okay, next question here is what generative AI, I'm sorry, with generative AI's popularity skyrocketing, what kind of guardrails do you recommend adopting or implementing to avoid inaccuracies and biases?
Um, I'll go first, Chris. It's. I think this is the time to explore rather than figuring out what we don't know. Um, Frankly, I have heard and read a lot on this topic that, hey, some movies and like what happens, it's like Terminator kind of stuff happen. I don't know, but that's what people are worried about. We are, in my opinion, decades from anything like that happening. We are in the beginning of this thing, and right now it's the time to actually allow people to explore rather than put guardrails around it at this point, because I don't see any major issue happening as long as they are obeying the current security infrastructures, you know, which exists, right? The HIPAA, the all of that, right? I think everything should be allowed. But you know, coming up with new guardrails at this point, maybe a few years downstream when actual issues are identified, but I don't see any major such issue identified as of yet. So maybe explore a little bit more before working on the guardrails.
Yeah, and I agree, directionally with that. I think it comes back to that game of singles as well. Don't believe you're going to create some silver bullet solution that you walk away from and does everything and doesn't introduce the challenges sort of surface in the question. Instead, look at how can you augment or enhance existing processes, allow people to continue to be a part of that process, and inform the model so you can improve sort of your understanding of where it aligns with a human decision or not, or a human result, and kind of keep that level of human AI integration high, so that, to Raj's point, we can learn the things we don't know. I think there's a lot of conjecture about bias and things like that, and we just don't have a ton of insight into whether that's real or sort of just fear driven.
Yeah. Great response. Okay, next question here. This is maybe following on the heels of that one. Is JAMA Internal Medicine recently reported that, quote, ChatGPT quickly authored 100 blogs full of healthcare disinformation. How can we be reassured that AI will only report facts in the future?
Chris?
If I could answer that one, I wouldn't be on this call right now. Kind of tongue in cheek. I think that, Niraj hit on the point in one of his bullets, this idea of you've got to be prepared for AI to be wrong. People are wrong. AI will be wrong. The whole concept of being based on experience and largely on prediction, I think, just makes that an imperative. And so I think the idea of will it present facts, and question of whose facts, and was it trained on facts? And Niraj, feel free to weigh in here, but I imagine if the model was trained on facts, it will prevent facts. If it wasn't, then it won't.
Yeah, I mean, JAMA is a pretty reputed journal, and there is, in the world of journals, right? There is peer review. There's a lot of peer. So basically, when there is an authoring of that sort which happens, right? It should go through peer review and get its regular. You see what I'm saying? It should go through the normal cadence that if I am going to author something versus and I just happen to be an expert on some condition, and then typically whatever I author, the paper I author or the journal article I write goes through a peer review process. So before it hits something of the magnitude of a JAMA, I'm sure JAMA is definitely not allowing that, but basically people should be smart enough to recognize, okay, hey, this one has no authority associated with it, right? Or this was generated, and the same guardrails which are there, which exist today, should be applied for those authored articles also. So that's best I can say right now. So
yep.
Okay, great.
Same as the models themselves, and same as people, right? You verify your sources.
Correct, exactly. Yeah.
Wonderful. Okay, next question here is it possible to use AI to predict patients' contact information? This is relevant during enrollment, when patients' number or address is missing, and it's challenging for healthcare workers to outreach with such limited info.
To predict contact information, that is
Maybe fill in the gaps.
Probably are going to go into some PHI world over there if we start doing. So legally, no, is what I would say. So ideally, we shouldn't embark, or no organization should embark on that. But maybe check with your security organization internally. So.
My guess is that question derives from the comment around, closing data gaps or data quality gaps
Okay.
earlier on. I think out of thin air, probably not. And Raj, maybe you can comment on some of the patient ID and other work that we're doing.
Yeah. So if it's a mistake in the patient ID and there is a
Right.
authoritative source of the patient ID which we can use for the training, then yes, we can correct an incoming, let's say a claim which comes in which has the wrong patient ID or the wrong provider ID, right? But if we have access to an authoritative source, the original list of physicians or the original IDs which have been used in the training, right? Then yes, it can be used further. But without having access to the authoritative source for the answers to those things, I don't think so.
I imagine you could train models on bodies of contact information from marketing sources, et cetera. Is that
True.
realistic, or is
Yeah.
that?
As long as they are freely available on the and legally and freely available, yes. But otherwise, no. So let me just draw the line. Basically, let's say I'm a health plan. I have a set of members. Claims come in for those members, and what I want to do is to make sure that the claims are complete, and I have a set of humans who are actually cleaning up any broken claims, right? We can replace that function, okay? But and as long as I have the correct information of those patients in some database, we can leverage that information for the training of the models to do the work the humans are doing. Okay, so that is very doable. Anything beyond that, where you are accessing any data source which is not available to the health plan in an internal world, it shouldn't be tried right now. So that's all. So, but it may be intrusive and breaking some privacy laws is what I'm concerned about. So.
Let's see. Okay, next question here is, what about AI in actual clinical workflows like patient visits and diagnosis, et cetera?
It's heavily used today. It is heavily used. Uh, where the challenges are is that healthcare is, for a good reason, the access to healthcare data is extremely strict, right? Like it is
Mhm.
not, it's very, very restrictive, the access. Okay, so collecting the training data for all of that, as long, what happens is, you if you are within an organization which is a small organization, you're probably not going to have all the training data needed to cover all different conditions and all different pathways in the workflow. Okay, but if you are a larger organization, probably you have the data, but then the fact that you have so much data, training the data is going to take time. So it's probably, you're talking about a multi-year project to do that correctly, but it is being used to a certain degree. Chris, you may have a couple of examples on where.
Yep. I think there's some, certainly with risk adjustment, where we're using it for suggested diagnoses or possible conditions. At the same time, we're seeing it used to recommend tests based on a set of clinical lab data, or to surface a set of potential diagnoses given a set of observations. And so, kind of back again to the broken record of game of singles, it's about decomposing a task or an activity into steps you can augment or enhance, in a lot of cases really just accelerate rather than replace. So you're trying to prompt memory of a physician of things they probably already knew, or trying to surface information that maybe hasn't been available to them yet so that they can consider it, but not necessarily replacing the decision or the conclusion or the recommendation of the physician or clinician.
Oh. All right, we've got time for one more for a quick answer from you both. Hopefully that's possible. We'll see. And then we'll need to wrap up. And the last question is this: how do you determine which type of AI, discriminative or generative, is better for a given use case?
It's all you, Niraj.
As I said, like the three big buckets are around predicting. Yeah, okay. So the way you go about it is you look at the data. A good one would be, a good segregation would be the data which you're going to use for training. Is it structured numerical data or is it text data? That's one line you can draw. If it happens to be purely numerical data, generative AI is probably generative AI. You can do anything with generative AI, but it's not going to add too much value. There are what are known as multivariate linear regression models, which are used for pure numerical data for recommending things like, as I said, stock prices, house prices, treatment prices, so on and so forth, right? So that is a very good. This is a long answer, but I'm sorry, but I just wanted to make sure. So if it's numerical data, you need to stay with certain types of models, which are mostly regression type of models. Okay, and a majority of the there's lots of classification models also you can work with. So you're not going to gain too much out of generative AI models because generative AI typically have to do a lot with textual data. Okay, so that's a good indicator. Beyond that, try it, download a few models, go to different websites, try a few models, read up on them, and see if a very easy way to look at it is just go to Kaggle, go to Amazon, go to the Google websites which they have developed, and see what certain models are used for. And based on that, you can quickly determine that this is a good model to use for this type of data. You will be surprised at the amount of research, data sets which are out there. And then you can compare your data set with that data set which is on Kaggle and say, oh, my data set looks best. And then, there are user groups where you can go and talk about it and say, hey, have you used this? And that would be the best way to go about figuring it out. So.
Okay, great. Well, unfortunately, we are out of time. There's more questions coming in, and there's a lot to discuss here. So obviously, this is a very rich topic. And guys, this was a fantastic presentation. I know I learned a lot. And we're going to send out the recording to everyone. So you're going to receive the slides and the recording, so you'll be able to review that. But as we close out here, again, I wanted to thank our speakers, and I wanted to encourage you all to head over to bbcexhibithall.com and check out the Edifecs virtual exhibit booth, which is going to be pulled up here on the slide momentarily. There we go. So if you go over there, there's a lot of really great resources, and you can read up on them and what they're doing and learn about kind of what they're doing in the value-based care space, and there's a lot there. So there'll be a hot link in the slides, but you can also just, again, head over to vbcexhibithall.com and check it out there. And then finally, if you would like to reach out to our speakers today, you can actually reach out to Abby if you would, and she can connect you appropriately. She's the VP of Sales, and she will take care of you there, or feel free to reach out to me as well, and I'm happy to facilitate an introduction as well. But thank you all so much for joining us today. We know that you have a lot of things going on and a lot vying for your attention, so we appreciate you spending the afternoon with us, and hope you join us for the next one. Thank you all so much. Have a great afternoon.
Garrett. Thanks, everyone.
Thanks, Garrett.
Bye-bye.
Thanks, Chris.